It's recording has started. Yep, go ahead.
When do you think you'll have the rest of the homework created?
Say again?
When do you think you'll have the scores updated? You know, like the scores you
Yeah, the homework
with
is,
the homework.
I'm still working on the homework. So what you're seeing, is.
Do you think you'll have it by before finals?
Yeah.
By next week. So.
Yeah. But this one is more important, to figure out the exam first because it's a lot more.
Oh yeah.
So the homework will be
But at
next.
the end, the homework is worth 20%. So
Yes.
It's
Yep.
worth one exam.
Yep. But if
Except
it does work, when you test the homework assignment, it should be okay. All right.
I got 4X.
So are there any questions? I mean, it's not like, when you look at your exam, you can actually figure out your score. So you have to log into Moodle to figure that one out. All right. So once everybody has settled down, because you can kind of figure out your grades in the lab or somewhere else. That's the good thing and bad thing of having cell phones, tablets, and laptop computers, because everybody can check right away and look at all the items, and there are a lot of items, right? I break some of the questions into 5 or 6 different points. So you have to kind of go through all the points and find out, okay, how did I lose some points or did something like that. So are there any questions? Now I can go over the scoring of the questions. So this way, I can help address some of the potential questions that you might have. So this part I cannot show because it's going to show the grades of people. So I have to hide it on the other side of the screen.
There's no good way to see our overall grade right now, is there?
There's no easy way to see your overall grade, but you know that your exam 2 and exam 1 are both 20% each.
Yeah.
And then the homework, I'm still in the process of grading a lot of those, so that's really kind of unknown. But from the 2 exams, you know kind of where you stand just from the exam. Okay. So what I want to do is to kind of explain, how I score the exam for each question. There are 4 questions, and in your grade book, they are sorted in a reverse way, because I want to put the question that I'm grading at the beginning, so that's why they are sorted in the reverse order. Exam 2, question number 1, I basically allocate points for data allocation. I know it's really hard to read because Moodle is picking a very small font. Data allocation has to do with using dot data and allocate the right size for the C construct. So when you look at int, it is supposed to be 32-bit, so a dot long or dot int will do it. And then the other one is a dot word because it's only 16-bit. So if you get one right but the other one wrong, you basically get partial credit for that. The next one is addressing mode. Okay, so do you guys want to figure out how it's graded, or do you want to listen to me so that you know how I graded it? Okay, so in terms of addressing mode refers to the proper use of the $sign for immediate operands, the lack of a $sign for direct operands, the use of a % for the registers, and also that you cannot move from one memory operand to another memory operand. So all of those will basically fall into the addressing mode part of your grade. The next one here says if then else. If then else refers to the logic of implementing a conditional statement. So this one is kind of broad. It includes the comparison, so you have to use the right polarity in the conditional branches after comparisons. Okay, and you also have to use the right sign. In other words, I do not understand why a whole bunch of people use the unsigned version of the conditional branches. So those people get some points taken off because of that. It looks at the overall structure of the conditional statement. It also looks at it looks for that unconditional branch at the end of the then case to get around the else case. Because without the unconditional branch inside the then branch, then it will fall through and actually execute the else branch regardless. Okay, is everybody kind of understanding what I'm saying? I can give you the sample solution too. I can actually pack it up and send it file myself, and I can give you the solution and also what I'm looking for. The next one is set in OR. In other words, I'm looking for people, I'm looking at people, I'm looking at submissions about how the OR, the logical OR is implemented. So that one has to do with the right polarity of the comparison again. Also, signed versus unsigned, flags used in the conditional branches. So those are all falling into the OR. The next one is 32-bit extension, because regardless of which version of the test you get, one of the variable is a 32-bit and the other one is a 16-bit. So you have to accommodate for the sizes, the difference of the sizes. In terms of comparison, now when you're comparing, you cannot just say, well, I have a 32-bit integer on one side, I have a 16-bit integer on the other side, so I'll just ignore the most significant 16-bit of the longer one and just compare the least significant 16-bit. You cannot do it that way, okay? Because that is not truly utilizing the entire number for comparing. Sign extension applies to, so when you're copying or when you want to compare two numbers, one is 32-bit and one is 16-bit. So the trick to do it, okay, and I think I talked about this in my video already because I actually talked about the solution right after the exam and I put it onto YouTube. So the proper solution is to first check whether the number is positive or I should say non-negative or negative. Because if it is negative, you have to fill up all the bits with ones, not zeros. Okay, but I also said that if you just fill up all the bits with zeros, I would count it as a perfect answer as well. There were quite a few people who got this point, which is fine. Okay, that's all good. And the last one here talks about operand width, the use of move W versus the use of move L, compare W versus compare long, and stuff like that. I'm not just blindly looking at a compare instruction at a certain place. I'm also looking from the context of how you use your variables and registers. So if you cast everything into 32-bit first, do all the conversion into 32-bit first, then you can use compare long all day long because everything is truly 32-bit. On the other hand, if you do the conversion or the sign extension at the very last moment, then you have to use compare word sometimes and compare long some other times. So that's basically what the operator or operand width is about. So I broke it up into roughly the 5 categories, and they do overlap a little bit in terms of how I score all of these points. So that's the first question. The second question has, okay. The second question is how to implement JNL label 1 using only certain restricted instructions. Okay, that's what the second question is about. So I break it out into 5 different subpoints. The first one, 2.2 start, is really checking whether you are starting with the instruction that you're supposed to start with. So anyone who reads the instruction, and anyone who reads the instruction, okay, let's say the instruction says you have to start with the JO instruction, and you just wrote down JO. That's like 1/5 of the point of this question already. Just by following the instructions and say, yes, I am starting with JO. I don't know how to do it, but I'm starting with JO. That's 1 out of 5 points already out of this question. And then the other 4, each one is specifying the effect and how do you implement it. In other words, with this one, I know it's really hard to read because the font is tiny. This one says NL.NO-NS. It means if the overflow flag is cleared, the sign flag is cleared, it should be considered as not less than, and therefore it should go to label L1. So if your code has the effect to do this reliably, okay, it's not just in some cases, yes, it will do it, in some other cases won't do it, but if you can do it reliably, you will get this point. And the same thing for all the other cases. So there are 4 possible cases because there are 4 possible combinations. Let me use